NASA's James Webb Space Telescope has hardly opened its eyes, and the universe is new, more mysterious, more beautiful than humanity's dreams. And all these little dots are stars?
All these little dots are galaxies, some of which are bigger than our own.
Breaking news. We may have just found potential evidence of intelligent life beyond Earth.
This is a huge discovery, and we think that it's a huge discovery. And that's the most exciting piece of this telescope, of this remarkable instrument we put in space, is finding things that we didn't expect, that we can't explain, because that means that we have to revise our understanding of the universe.
Well, JWST is so phenomenal that if you spend enough time, you could probably find any galaxy that ever formed in the universe. It's really that powerful.
Researchers have made a bold claim. They've announced the discovery of a new planet unlike any previously identified. NASA, famous for its groundbreaking research, has revealed that this newly found planet is remarkable not only because of its size and position, but also because it emits light that appears to be made by someone else. Could this revolutionary discovery be a sign that we are on the edge of solving mysteries that will fundamentally alter our perception of the universe? Does this raise questions about the possibility of life existing on planets beyond our own? As we delve into NASA's remarkable discoveries, we may soon find out the truth about these extraordinary illuminations. In 2007, NASA launched the Dawn spacecraft with a mission to examine a few of the most captivating objects in our solar system. Dawn, equipped with 3 ion engines, embarked on a journey that began with a 14-month study of Vesta, the second-largest asteroid in the belt. Dawn transmitted back intricate images and data that revealed the complex surface of Vesta and its rich geological history. Upon completing its mission at Vesta, Dawn proceeded with what was arguably the most exciting phase of its journey, an in-depth examination of the dwarf planet Ceres. Thanks to its ion engines, Dawn was able to leave Vesta's orbit and head toward Ceres, a feat traditional chemical propulsion methods could not have accomplished. These engines provided a constant thrust that allowed Dawn to cover large distances and establish a stable orbit around Ceres. Discovered in 1801 by the Italian astronomer Giuseppe Piazzi, Ceres is the largest object in the asteroid belt between Mars and Jupiter. For many years, it was regarded as the smallest dwarf planet in our solar system until its reclassification in 2006. With an estimated diameter of 950 kilometers, Ceres is the most extensive and massive body in the asteroid belt, making it one of the most intriguing objects due to its distinct features. Scientists eagerly anticipated the first comprehensive images of this mysterious world, which revealed numerous bright spots all over its surface, particularly within a large crater known as Akata crater. These bright spots immediately attracted substantial interest among the scientific community. Before the Dawn mission, the best images we had of Ceres were blurry, low-resolution ones captured by the Hubble Space Telescope. Very little was known about the dwarf planet, and the opportunity to acquire close-up images promised exciting new insights. The Dawn mission aimed to enhance our knowledge of the solar system's formation and the role water played in the development of planetary bodies. The bright spots on Ceres, also observed on other asteroids, were believed to be composed of highly reflective materials, possibly salts left behind by sublimated water. This discovery nudged scientists toward the possibility of cryovolcanism on Ceres, a phenomenon where volcanoes erupt not molten rock, but liquid water or brine. What exactly these mysterious lights are, and what they say about Ceres, is still unknown. Could they be evidence of ongoing geological activity, or might they point to something even more remarkable? Ceres stands apart from other objects in the asteroid belt due to its size, mass, composition, and potential for containing water and ice. Unlike typical rocky asteroids, Ceres has a composition more like that of a comet, implying it may hold important secrets about the early solar system. After 2 years of travel, the Dawn spacecraft finally began its approach to Ceres in early 2015, marking a significant turning point in its mission. As it prepared to send back the first close-up images of the largest object in the asteroid belt, the spacecraft drew closer to Ceres, revealing a world previously hidden. The first images displayed a cratered surface indicative of a long history of impacts. However, it was the gleaming areas within the dim, rocky terrain that captured the attention of scientists and space enthusiasts. As the resolution of the images improved, scientists developed numerous hypotheses regarding these locations. Could they be patches of ice reflecting sunlight, or might they represent something even more exotic? Speculation ranged from mineral deposits to potential signs of cryovolcanic activity. To everyone's astonishment, closer inspection revealed that the brightest spot was not a single feature, but a grouping of several distinct locations. The most widely accepted explanation was that these spots were deposits of salt left behind by the sublimation of water. This suggested that Ceres may have, or still possesses, some geological activity capable of bringing water or brine to the surface, where it evaporates, leaving behind bright, reflective residues. These findings challenged previous assumptions and presented a brand new image of a dynamic and intricate world. The possibility that groundwater or brine pockets exist beneath the surface raises intriguing questions regarding the potential for life elsewhere in our solar system. Ceres is often described as an icy world with a rocky yet porous surface. In contrast to most asteroids, which are primarily composed of metal and rock, Ceres stands out due to its distinctive composition. Its surface is made up of a mixture of water, ice, and hydrated minerals, including carbonates and clays, which give it a less dense structure than its rocky neighbors. This suggests that Ceres contains a significant amount of water. Its rocky surface is porous, with ice and other volatile materials trapped inside, more common than typical asteroid. Scientists believe that Ceres has a distinct interior consisting of a muddy mantle and a core rich in water ice, which accounts for about 50% of its total volume. The mantle is thought to be surrounded by a brine and rock mixture, and the core may be made up of denser substances such as silicates. The presence of substantial water ice suggests that Ceres may have hosted liquid water in the past, particularly if its core was heated early on by radioactive decay. This internal structure sets Ceres apart from other asteroids and raises fascinating questions about its potential for geological activity and the role of water in its development. Moreover, the discovery of ammonia-bearing clays on Ceres points to the possibility that the dwarf planet may have formed in a cooler region of the solar system before migrating inward. The presence of ammonia may also lower the freezing point of water, supporting the existence of these surface brines. Perspectives on the composition and the history of Ceres not only enhance our comprehension of this enchanting dwarf planet, but also provide useful clues about the processes that govern the genesis and development of icy bodies throughout the solar system. Cryovolcanism is an intriguing and comparatively uncommon geological phenomenon, especially when compared to the more familiar volcanic activities on Earth. Unlike traditional volcanoes that expel molten rock, cryovolcanoes, frequently referred to as ice volcanoes, eject substances like water, ammonia, or methane. These substances can exist as liquids or gases in extremely cold environments like those found on Ceres. Cryovolcanoes on Ceres operate by allowing dissolved briny water to reach the surface. When the salt water comes into contact with the vacuum of space, it rapidly sublimates, turning directly from a liquid or solid to a gas. This process leaves behind glowing, reflective salt deposits, which form the bright spots observed on Ceres' surface. The most famous of these bright spots is situated in the Achater crater, specifically in a region known as Spot 5. This area has garnered significant attention due to its high reflectivity and the regular shifts observed by the Dawn spacecraft. These fluctuations are believed to be caused by water sublimation, suggesting that activity could still be occurring, or may have recently occurred, on Ceres. In addition to Spot 5, Ceres hosts other bright spots, each with unique characteristics. These locations are not restricted to a single region but are scattered across the dwarf planet's surface, indicating that cryovolcanism could be a widespread phenomenon on Ceres. The presence of these bright spots emphasizes the active and dynamic nature of Ceres, challenging previous presumptions that it was a geologically dormant world. As the Dawn spacecraft continued to record more specific images, a wide variety of surface features emerged. Ceres' surface is covered with a number of craters, each of which tells the history of this dwarf planet. Let me know your thoughts in the comments section, and if you enjoyed this video, remember to like and subscribe. As the Dawn spacecraft carried on its scientific observations, the scientific community remained intrigued by the planet's mysteries. Each new discovery raised more questions about Ceres' history and its potential to harbor conditions that could support life. The presence of bright spots and the emerging picture of cryovolcanism painted a portrait of an active world, far more dynamic than originally thought. This discovery suggested that Ceres might not only be an ancient relic of the solar system, but also a world in which geological processes, such as the eruption of ice and brine, are still shaping its surface. The fact that Ceres could continue this activity despite its small size challenges conventional thinking about celestial bodies in the asteroid belt. Traditionally, it was believed that particularly small, cold bodies were geologically inactive and frozen in time. But Ceres' activity hints that even in the cold, old reaches of the solar system, the right combination of heat, water, and salts might be sufficient to power cosmic eruptions. Another significant aspect of Ceres is its potential to unlock important clues about the history of water in the solar system. Water is a key ingredient for life as we know it, and realizing that it might exist in liquid or brine form on Ceres opens up new possibilities for the existence of life in environments far from the warmth of the sun. The notion that water ice and liquid water could have once existed on Ceres suggests that other similar bodies in the solar system, such as Europa, Jupiter's moon, and Enceladus, Saturn's moon, may also host conditions favorable for life, making them prime targets for future exploration. The possibility of cryovolcanism occurring on Ceres also raises deeper questions about the mechanisms that drive such processes. How does the water beneath Ceres' icy crust remain in a liquid state despite freezing space temperatures? One possibility is the presence of a heat source within the dwarf planet itself, such as radioactive decay or tidal heating from gravitational interactions, keeping the water sufficiently warm to remain liquid. Understanding the nature of these internal heat sources might offer important insights into the geological development of additional icy bodies in the solar system. Each crater on Ceres, distinct in its formation, offers a glimpse into the forces that have influenced not only Ceres but many similar bodies throughout the solar system. Whether these impacts were the result of asteroid collisions or other cosmic occurrences, they contribute to the unique character of Ceres and its role in the broader story of solar system development. Moreover, the presence of ammonia clays on Ceres offers another fascinating clue about its history. Ammonia is known to lower the freezing point of water, which could have allowed liquid water to exist on or near the surface, either today or in the past. This finding indicates that Ceres may have formed in the colder outer regions of the solar system before migrating inward toward its current location. This migratory history could explain many of the intriguing features observed on its surface, including the presence of ammonia and signs of cryovolcanism. As scientists continue to study Ceres' surface and interior, their findings are reshaping our understanding of planetary formation, geological activity, and the possibility of life beyond Earth. Once regarded as just another small, cold asteroid in the belt, Ceres has developed into an intriguing world that challenges our expectations and invites us to re-evaluate the possibilities of distant icy worlds. The Dawn spacecraft, as a result of its years of meticulous observation, has played a pivotal role in uncovering these new details about Ceres. The mission, which has provided the most comprehensive data and images of this distant dwarf planet, continues to be the foundation of our investigation into the solar system. Each new image transmitted back from the spacecraft reveals additional secrets about the planet, displaying a world that is changing and complex, one that was once largely unknown. These discoveries are just the beginning of what looks like an ongoing examination of the enigmas of the outer solar system. In the coming years, the scientific community will no doubt continue studying the data sent back by Dawn, searching for further clues about the potential for life on Ceres and similar bodies in the solar system. Researchers are particularly interested in studying Ceres' unique geological features, which indicate that it continues to evolve despite billions of years. One important aspect of this ongoing evolution is the presence of water in its various forms, which plays a critical role in shaping the surface.